Okay, we're going to be looking at lesson 7-1, and we're going to look at multiplication of exponents. Now, it's really important. Everything I'm going to teach you today is about the exponent, not about any numbers that are out in front, and I'll talk more about this in a little bit, but you have to understand I'm working on exponents only, okay? We're going to be looking at how to multiply what's called a monomial. We're going to talk about what a monomial is, and then we're going to simplify expressions when we're doing multiplication. Now, you should have already done this top part. If not, you'll need to backtrack and do that after. And so right now, we're going to go ahead and zoom in here on the word monomial. Monomial has three parts to it. It can be a number, a variable, or the product of a number and variable. Okay, so if I'm thinking about a number, so like 3, 4, 1/2, 3/4, those are all different numbers. A variable could be x, or you could have multiple variables, hence why I have this little s right here, okay? So it could be more than one variable. So I could have something like r s t to the third. It's okay to have exponents, and it's okay to have multiple variables. Now on the third part here, I can have the product. Remember, product means multiplication. So I can just simply multiply like 3 and x, or I could say 1/2 rs, because again, I can have more than one variable. Okay, so again, a number, a variable, or when I multiply numbers and variables. Okay, so now on number 1 here, it says circle all the monomials. So we're going to circle all the ones that apply to these three rules up here. Okay, so I'm going to start by looking at the number 16. Well, yeah, the number 16 is going to work because it's a number. Okay, so I'm going to go ahead and circle that one. The next one would be 1/2 xy. That works because it's the product of a number and variable. So I'm going to circle that one. Now, when I look at the next one, I've got x minus y, all right? This guy right here is no good. We cannot have that, so this does not work. It's for products only, not addition and subtraction. The next one I go to is negative 14 times x. That works. It doesn't matter if my number's positive or negative. All right, and kind of moving over here. My next one is v. Okay, v does work because it's just a variable, and that's allowed. 3/4. Yep, that's good because it's a number. Doesn't matter if it's a fraction or not. Now, when I look at this guy, I have some problem areas again. I have all these pluses here. That's no good, all right? So this is not a monomial. It can't have lots of parts. Now, when I look at these last two here, one of these will work and one of them will not, okay? And so what we have to look at is there a way to rewrite it so that it looks like a number times a variable? So what I'm talking about here is if I look at this would be saying -5 times, and then the r has to stay on the bottom. You can't move it up. So when I put the 1 up there, this is no good, all right? I cannot have a variable in the denominator or on the bottom, okay? So in other words, you can't, oh, I forgot the word can't. Let's put that in there. Can't divide by a variable. Okay, now if I look at this next problem here, if I put a 1 in front here, I can rewrite this guy right here as negative 1/5. Okay, so I have negative 1/5, and the r either stays on top or goes out to the side. That's okay, because it's saying a number, so negative 1/5 times a variable. So it's okay to have the number on the bottom because we're just saying it's a fraction. So the number on top, or sorry, the variable on top is good. Variable on bottom is not going to work out. So this guy will not work, and this guy will work. Okay? So kind of the things that won't work is when I have a variable on the bottom, or I have a lot of the addition subtraction. Okay? All right, so our next vocabulary word is constant. It's a monomial, so that's a number, a variable, or the product of a number and variable. That is a real number. Okay, so the number out front is called a coefficient. So constant and coefficient, so this guy and this guy are kind of saying the same thing. Okay, it's just talking about the number out front. So when it says name the constant, well, when I look at the constant here, this is just a 2. 2's out front. So on the next one, 1/2. Now when I have the letter D, remember there's always a 1 in front there, so 1 would be my constant. Okay? And then on letter D here, 4 is a number. We're just going to put 4 down. I know there's no variable there, but that's the only number there. Okay? All right, we're going to go ahead now and move to the second page. All right, so what I'm going to be doing is we're going to be simplifying expressions. And if I look here, what we're going to be looking at are exponents. And I'm going to be teaching you the exponents, like on this one, what to do with the 3 and 5, what to do with the 3 and the 7, the 4 and the 5. So when you're looking through here, I'm not teaching you about 6 and 2. All right, I'm not teaching you about 3 and -7 because you already know how to take 6 times 2 and 3 times -7. But what I'm going to teach you is how do you change these exponents, okay? So we're going to zoom in here on letter A. And the rule of thumb is when you're multiplying two things with the same base, and when I'm talking about the same base, I'm talking about the b's, okay? So when they have the same base, you're going to add the exponents. So in this case, I'm going to have b, because that's my base number, and then 3 plus 5 is 8. Okay? Now moving on, so if I look at letter B here, I'm still going to add those exponents up because I have an n and an n. I have the same base, so I'm going to take 3 plus 7 and get 10. Now, like I said, I am not going to teach you new rules about 6 and 2. You already know that 6 times 2 is 12. So 6 times 2 is 12. That goes out front. So you have 12 n to the 10th. And remember that this is a monomial. It's a number times a variable. Exponents are okay. All right, so letter C. All right, so again, you're going to multiply. So 3 times -7 is -21. And then add up your y's. 4 plus 5 is 9. Okay, so again, side by side, we're going to add the exponents. All right, so now what do we do when we have lots of exponents? All right, you're still going to add up the bases. So here I have a p, and here I have a p to the third. Now realize this p still has an exponent of 1, so we are still going to be adding. So we're going to have p to the fourth. 1 plus 3 is 4. And then we're going to add up the t's and get 3 plus 4 or 7. Now, the number up front here, the 3, is technically multiplied by a 1 right here in front. Remember, any variable has a 1 in front. So 3 times 1 is just going to be 3. Okay? All right, so let's look at the next one. Again, multiply those front numbers. So -4 times -6 is 24. Add the exponents. So r to the first, r to the fifth, has 6 r's. X squared is 4x's. And t to the third and a t to the first is t to the fourth. And that will be your answer. Okay? All right, so the rule here, product of powers. Okay? To multiply two powers that have the same base, so we're talking about like the same letters, n and n or t and t, add their exponents. Okay, add their exponents. Now, I'm going to shift gears just a little bit, and what we're going to look at is what happens when we've got all these little exponents. So exponent to exponent is what we call this, or little guy to little guy. Sometimes I'll refer to it as that. So what happens when we have things like that? So basically, I have, if you kind of look down here on example 3, I have an exponent on outside the parentheses. I have a 3 outside the parentheses, a 5 outside the parentheses. What do I do with that? Okay. All right, so I'm going to look here at example 2. Now in this case, the 2 is still your base. So in this case, it's a number instead of a letter. So we're still going to leave the 2. We're going to leave the base alone. And the rule of thumb is when you have exponent to exponent, or all these little guys, you're going to multiply. So I'm going to take 3 times 2 times 5. So 3 times 2 is 6 times 5 is 30. So I have 2 to the 30th power. Okay? All right, so do the next one here. Again, keep your base, so keep the 3 there. And then you're going to multiply these guys. 2 times 2 is 4, times 4 is 16. So for right now, your answer is going to be 3 to the 16th. And I'll show you later how to put that in your calculator once we return to class. All right, so simplifying expressions. So now what do we do when we have more than one thing on the inside? So we have this variable or this exponent on the outside, and it needs to go to all the parts on the inside. Okay, so if I look here, this has got t to the first and w to the third. This 4 is going to drop into both parts. And when you drop it in, that's just multiplication. All right, so 1 times 4, I'm going to have t to the fourth and w to the 12th. 3 times 4 is 12. Okay, so like I said, little guy to little guy, you're going to multiply. Okay. All right, example B here. I'm going to drop that 3 into all 4 parts here. So if I look at that, that's going into all 4 parts. So 3 to the third is 27. Remember, it's 3 times 3 times 3. Okay, y to the third, because there's a 1 there, 1 times 3 is 3. X to the third, 1 times 3 is 3 again. And now for z, I'm going to have 3 times 3 or 9. Okay. All right, so now we need to look at what happens. We're going to drop a 5 in now. Okay, so now think about this. This is negative 2 to the 5th. So that's saying negative 2 times negative 2, and there's going to be 5 of them. Okay, so if I look at this, this is 4 times the negative 2 is negative 8. I'm going to drop in the next negative 2 and get 16. And then drop in that last negative 2 and get negative 32. Okay, so what I want to kind of talk to you about here, anytime you have an odd exponent, okay, so odd exponent, and what we're talking about is if our number's odd here, sorry, if we have a negative number with an odd exponent, so negative number with odd exponent, it stays negative. So the number will stay negative, okay? So now I'm going to kind of zoom in here and look at something else. So if I had negative 2 to the 4th, that would be negative 2 times negative 2 times negative 2 times negative 2, right? Okay? So I would multiply these two together first and get 4, drop in that negative 2, and get negative 8. Okay, and then drop in this other negative 2, and I get a positive 16. Okay, so anytime I have a negative number with an even exponent, it will stay positive. Now, like I said, I'm going to teach you how to do calculators and whatnot on all this, but it helps to know that in case you don't have one. Okay, so just kind of keep in mind that a negative exponent to an even will always be positive. And if I have a negative, so a negative here with an odd exponent, the answer will always be negative. All right, so let's finish it up. I've got negative 32, x to the 15th, y to the 25th. Again, I'm multiplying the exponents. 3 times 5, so 3 times 5, and then 5 times 5. All right, now don't be scared of fractions. That squared is going to go to the 2 and to the 3, okay? And then you're also going to drop it in right there as well. So I'm going to have 2 squared is 4, 3 squared is 9, and then it's going to be m to the 4th, okay? So don't worry about the fractions. Just go ahead and do the top number and the bottom number and just leave it in fraction form. All right, and the next problem here. All right, so now if I look at this guy, you guys see how we've got these bracket things here, okay? That just means that I'm going to work both of these exponents. Now, I think it's the easiest is to go ahead and just multiply these guys together and call it 6. And then what I'm going to do is I'm just going to drop that 6 in. So right now I'm going to have negative 2 to the 6th and y to the 6th. When I drop that 6 in, remember there's a 1 right here with that y. Okay, now negative 2 to the 6th, since it's an even exponent, I know I'm going to get a positive answer, okay? And 2 to the 6th ends up being 64, and then y to the 6th. Okay? All right, so our rule is anytime we have exponent to exponent, we are going to multiply the exponents. Okay? All right, if there's an assignment for you to complete, then you need to complete that. If not, this concludes the notes right now for lesson 7-1. Thank you.